Okay, well, finally, we're going to work through an example where we take the Laplace transform where we have a piecewise function, so a discontinuous right-hand side. Then we're going to solve for our solution and take the inverse Laplace transform to find it back in T world. Okay, so we're going to be bringing these pieces together. Okay, so we're going to start by rewriting our problem. So here this says that the derivative of y plus y is equal to this piecewise function that's equal to 0 until time 1 when it turns on, and it is now equal to 5. So take a moment and try and write this out using step functions. Okay, so we should end up with y prime plus y equals 5 times u1 of t. And we're going to note that y at 0 is 0. Okay, we are ready to take Laplace transforms. So our first term here gives us s times capital Y minus little y at 0. And then the Laplace transform of y, we're just writing as capital Y. And then 5 times u1 of t. Well, we can use our formula for this. Here our function is equal to 1. So this is going to be 5e to the negative s times the Laplace transform of the function 1 that's been shifted. But if you're constantly equal to 1, there's no shifting going on. And so this is going to be 5e to the negative s times 1 over s. Okay, so this gives us s times y plus capital Y equals 5e to the negative s times 1 over s. Okie dokie. We can also find this on our formula sheet. If we head over there, we see UC of t, I was calling it UA of t, is going to be e to the negative as over s. All right, we're going to solve this for y. So we have s plus 1 times y equals 5e to the negative s times 1 over s. We solve for y. So I'm going to just divide all of this stuff over. This e to the negative s term is going to come out in front, and we really aren't going to really touch it much. So I have 5 on top, and an s plus 1 on the bottom. Okay, now we want to use our reversal. So if you had e to the negative as times capital F of s, this is UA of t times little f of t minus a. Okay, our inverse Laplace transform of capital F that we then shift right by. Okay, so our job is going to be to first find the inverse Laplace transform of this 5 over s times s plus 1. And we can do this using our friend, the partial fraction decomposition. Take a moment and try this out. So we can use cover-up method here. A is going to be 5 over s plus 1, evaluated when s equals 0. So this is just 5. And B is going to be 5 over s, evaluated where s equals negative 1. And so this is equal to negative 5. So 5 over s minus 5 over s plus 1. F of t here is going to be 5 minus 5 e to the negative t. All right, and so we're about ready to write down our solution. The function y of t is going to be equal to the shift of our function. We see that this shift from this exponential, here we have this negative as, so a here is equal to 1. So this tells us u1 of t times 5 minus 5 e to the negative t minus 1. And we can either leave it like this, or if we wish to, we can expand a little bit, so we get e to the 1 minus t. All right, so sort of as we might expect, we didn't have, we changed our function at time 1, and so in our response function, we see that we see a change happening at time 1.